Welcome to today's lesson. Today we will be able to identify the key features of a rational function, and we will be able to explain how to find the key features of a rational function. So let's take a look at today's do now. Alright, let's take a look at today's do now. Answer the following. Using the graph, state the domain and the range of the function using interval notation. So pause this video, find both, and we will get back together once you are done. All right, so my domain goes from negative infinity to -3, starts up again at -3 to positive infinity. So I see that green wall, vertical asymptote. For my range, it looks like we are heading in both directions towards the y value of -2. So we are starting at negative infinity to -2. That's our wall, from -2 to positive infinity. So we have two types of asymptotes here, which is what we are going to be looking at today. So what is our thinking for today? What are the key features of a rational function? So a rational function is a function that looks like a fraction with a variable in the denominator. We will need to know and find key features of rational functions. So what are our key features? We did do some of them before, finding the domain and the intercepts. So with a rational function, these two pieces of information are very important. The domain is found by setting the denominator not equal to 0, solve and exclude those values from the domain, and these are our restrictions. The x-intercept, we will set y equal to 0 and solve for x, which normally means that we're going to be setting the numerator equal to 0 and solving for x. To find the y-intercept, we are setting x equal to 0 and solving for y. So if we were asked to draw, these are the things that we will have to input into our drawing of these rational functions. Besides these things, there are two other important pieces of information. They're our asymptotes. So an asymptote is a line that continually approaches a given curve, but does not meet it at any finite distance. How do we find asymptotes of rational functions? So we have two types of asymptotes. We have a vertical asymptote, VA for short, and we have a horizontal asymptote, HA for short. A vertical asymptote is an invisible vertical line in which the function approaches but never ever reaches. The steps for finding these vertical asymptotes: we're going to factor the function, numerator and denominator if possible, cancel any like terms, set the denominator to 0, and write your answer as an equation. So the vertical asymptote and the domain are somehow linked together. The vertical asymptotes are invisible walls. The domain does not include this visible wall. It's a kind of our stop. So for a horizontal asymptote, we have an invisible horizontal line in which the function approaches. Some functions will actually cross over this horizontal asymptote. So it's not like the vertical asymptote in which the function will never touch. The horizontal asymptote, some functions will slightly cross over it and linger around the horizontal asymptote. So how do we find this horizontal asymptote? There's three types of situations. If the top degree is less than the bottom degree, then the horizontal asymptote is set equal to 0, which means that you have a horizontal asymptote at y equals 0. If the top degree is greater than the bottom degree, there is no horizontal asymptote. And the third case, if the top degree is equal to the bottom degree, then you will need to divide the leading term's coefficient and simplify. So how are you going to remember all of these situations for the horizontal asymptote. There's an acronym. We have Bob Yo, we have Bot No, and we have Eats DC. Bob Yo means big on bottom. Big on bottom means the exponent is larger in the bottom. If the exponent is larger in the bottom, Bob, then Yo is your horizontal asymptote. What does Yo mean? Y equals 0. So an example of this would be, let's say we have our function f of x equals, we have x plus 1 for my numerator, and my denominator would be x squared. So here what we're focusing on is the exponent of the x value. So the exponent is larger in the bottom, which means that y equals 0 would be your horizontal asymptote. Second case, we have bot no. Bot no means big on top. Big on top, no. Bot no means no horizontal asymptote. So if we have our function f of x equal x squared over x plus 1, again, we're focusing on the exponent. Here we have x to the second, x to the first. We have a big on top case, which means there is no horizontal asymptote. There is a different type of asymptote here, which is known as an oblique asymptote. So eats DC, what does this mean? Eats DC means exponents are the same. If the exponents are the same, we DC. What does DC mean? We divide coefficients. Okay, so what would this be? Let's say we would have our function f of x equal 3x squared minus 1, 6x squared plus 1. So here if I'm looking at this, I have my coefficient of 3, our coefficient of 6, and the exponents are the same. So since the exponents are the same both on top and bottom, we divide those coefficients. We would divide 3 divided by 6, giving us our horizontal asymptote of y equals 1/2. The horizontal asymptote is always a horizontal line, so it's always going to be a line that says y equals. A vertical asymptote is always going to be a vertical line, which is always going to have an x equal value. So let's take a look at our examples. So example number 1, working with rational functions, we have given the function f of x, x minus 1 over x squared plus 5x plus 6. We want to find the vertical asymptote, we want to find the horizontal asymptote, and we want to find our x and y intercept of this function. So to find the vertical asymptote, the horizontal asymptote, whenever you are given a rational function, you have to look at the numerator and the denominator and ask yourself if you can factor it. So I am going to actually factor the denominator. So if we were to factor this denominator, we would have a factor of x plus 3 times x plus 2. When we factor, the reason that we are factoring is because we're going to see if we can cancel anything. Here, factoring wasn't useful, so I'm actually going to work with the original function. Okay, so what are we doing? Vertical asymptote. To find the vertical asymptote, we are going to set the denominator equal to 0. So if I set the denominator equal to 0, here I would look at the factored form, set it equal to 0, meaning that I have 2 vertical asymptotes. My vertical asymptotes are x equals -3 and x equals -2. If I ask you to identify the domain will not include these values. So very quickly, I'm just going to add the domain piece right under. The domain would be from -∞ to -3 union. from -3 to -2, union from -2 to positive infinity. So we would have two walls. Our walls would be somewhere here and somewhere here, our vertical asymptotes. For part B, we are going to find the horizontal asymptote. So to find the horizontal asymptote, what we are going to be determining is where is the exponent larger? Is it larger on the top? Is it larger on the bottom? Or are they exactly the same? So here we have a large on bottom case because we have an x to the first and an x to the second, meaning big on bottom. Big on bottom, that is our yo, which means that our horizontal asymptote is the line y equals 0. For part C, we are going to find the x and the y-intercept. For the x-intercept, we know that is a number, comma 0, which means that we're going to set 0 for f of x and get our x-intercept to be 1, comma 0. To get our y-intercept, we are going to set 0 for x, giving us our y-intercept of 0, comma -1, 6. So if we were asked to draw this function, what we would need to input in our drawing is the vertical asymptotes, the horizontal asymptotes, the intercepts, and maybe a couple of more points. For number 2, we have given the following function f of x. We want to find the vertical asymptote, horizontal asymptote, and the intercepts again. So we are going to do the same thing. We're going to start off by factoring numerator, denominator, seeing if we need to cancel anything out. If not, then we can go ahead and find the vertical and the horizontal asymptotes as well as the intercepts. All right, so here is our factored form. Factor form, again, not useful because we can't cancel anything. So for part A, what we are going to do is find the vertical asymptote, and we do that by setting the denominator equal to 0. So our denominator is 2 times x squared minus 2. I'm going to set that equal to 0, solve for x. So divide that by 2. Plus 2 on both sides, square root, we would have x equals positive or negative square root of 2. So we have our two asymptotes here as x equals negative square root of 2, x equals positive square root of 2. For part B, we are going to find the horizontal asymptote. So what we are focusing on is the original function here I'm going to look at. We have the same exponents both on top and bottom. So what we have to do, this is our eats DC case. Exponents are the same. We DC, which means we divide coefficients. So what is our coefficient for our numerator? A 1 divided by the coefficient in the denominator, which is a 2, giving us our asymptote of 1 over 2. And it is a line that is y equals. The last piece here is the intercepts. So I'm going to make you guys find your x and your y-intercept, and we'll see if we have the same values. All right, so for our x-intercepts, we have -5, 0 and 2, 0. For the y-intercept, we have the point 0, 5 halves. So again, if we were asked to draw, these would be all the key features that we would need to input into our drawing. So that is all about rational functions. So keep learning, keep growing, and I will see you in our next video.